actual writing of ionic compounds. How do you write them? So the first rule for writing an ionic compound is ionic compounds must be neutral. That is, the sum of positive charges must equal the sum of negative charges. For example, if you have calcium 2+, calcium is an alkali earth metal, forms a 2+ cation, making an ionic compound with fluoride, a nonmetal. The sum of the charges for the formula for the ionic compound must equal 0. So what does that mean? Common shortcut is if you move the superscript charge and make it the subscript for the opposite ion, that negative charge, make it the subscript for the opposite ion, and write that as a formula, CaF2, 2, make that the subscript. There's 2 fluoride anions, and then 1 calcium cation. That is the formula for calcium fluoride. Then to check, those charges are in fact equal. Calcium has a 2+ charge, those charges cancel each other. Fluoride has a -1 charge, and there are 2 of them in our formula. 2 plus -2 is 0. The sum of the charges equals 0. And there are a 2+ charge, a -2 charge, everything 0. Another example. We have manganese 6+, and oxide O2-. We do our trick. The 2- form 2 manganese, have 2 manganese cations, 6+, 6 oxygen or oxide anions. So now, magnesium 2, 2 manganese cations, 6 oxide anions. We'll check to make sure that everything is neutral. 2 times 6+ is +12. 6 times -2 is -12. That is equal to 0. That compound is neutral. But another rule. Ionic compounds must be written as empirical formulas. So an empirical formula is the lowest whole number subscript for each element. This is for ionic compounds. Molecular compounds are different. So what that means is 2 and 6 have a common number. They're both divisible by 2. That the correct formula for this compound is MnO3. The correct formula. Still neutral, you would have 1 times 6, 6, 3 times minus 2, minus 6, you would still have a neutral compound. So, first rule of of writing an ionic formula, the sum of the charges must equal 0. The compound must be neutral. So how do you determine what the charge is for an ionic compound given a formula? You'll be given a periodic table on exams, and the periodic table is something that you need to be familiar with. But if we look at our first example, aluminum oxide, look at aluminum oxide, how you get that name in a future play posit. But oxygen's a nonmetal, forms anions. It's 1, 2 electrons to form its most common anion. So 2 minus. If you write minus 2, that's okay. So that means that the overall negative charge from the oxygen in the whole ionic compound is minus 6. 3 times minus 2 is minus 6. Okay. That means that aluminum must be plus 6. Remember those rules? Plus 6 minus 6 is equal to 0. But you have 2 aluminum cations. So plus 6 divided by 2, since you have 2. Means that the charge of the aluminum is 3 plus. And we can confirm that by looking at the periodic table. Aluminum is here. So it loses 1, 2, 3 electrons to become like neon. Okay, from 13 to 10. And that's confirmed in the periodic table. But the charge for each aluminum cation is plus 3. Okay. 3 times 2 is 6. The charge of each oxygen anion is minus 2. 3 times minus 2 is minus 6. The next example, sodium plus 1. It's here in the periodic table. It forms a plus 1 cation, loses 1 electron to become like neon. And then the overall charge, or positive charge for this compound, since there are 2 sodium atoms, or ions, is plus 2. And what you should recognize is that CO3 is a polyatomic ion. It's one of the polyatomic ions that you have to memorize. The overall charge of CO3 has to balance, has to be equal and opposite in charge for the ionic compound to be neutral. So the whole charge of carbonate is minus 2. When it comes to calculating oxidation states in further chapters, you'll be able to calculate what the charge is for the carbon in the polyatomic ion. But the sum of these charges will be equal to 0, will be neutral, and that's the charge. Positive 1 for each sodium cation, and minus 2 for the whole carbonate anion. Naming ionic compounds. So here are the rules for how you name them. Rule number 1, cation is unaltered. Its name is unmodified. So our example here, aluminum, you don't change the writing or the spelling of the name. It's aluminum. So aluminum. The anion, on the other hand, you do change its name. Oxygen is a nonmetal. It's not a polyatomic ion. So it goes from oxygen to adopting an IDE ending to oxide. So nitrogen becomes nitride, and so on. So they adopt an IDE ending. So aluminum oxide. That's how you name this compound. The next compound is composed of polyatomic ions. So you have to have those committed to memory. This first is the only cation, polyatomic cation you have to know is ammonium. And then the next compound is chromate, compound, ion. From things to memorize. You either know them, you've got them committed to memory, or not. So the name of this compound is ammonium chromate. And then next, if you have an element that can form multiple charges, multiple cations, you should look out when you see transition metals. So the transition metals. Which iron is a transition metal. You have to write the charge of the cation in Roman numerals in the compound to indicate what its charge is. So in this example, you have to deduce what iron's charge is. Nitrogen, look on your periodic table, in an ionic compound forms a 3- charge. Okay, so you have 2 of them. So the overall negative charge contribution is -6. 2 nitrogen anions times -3 is -6. So that means the overall charge for all of the iron in the formula unit is +6. +6 minus 6 is equal to 0. But you have 3 iron cations in the formula unit. 6 divided by 3 is 2 plus, or +2. So the charge of each iron atom is 2 plus, or iron cation is 2 plus. So to properly name this, this is iron 2, Roman numeral 2, 2 I's, nitride. So nitrogen, you drop the OGEN, you add the IDE ending. And those are the rules for naming ionic compounds.